Okay, so again, for numbers 1 and 2, put it in the correct order and tell me the leading coefficient and the degree. Now, for number 3, it's just a subtraction problem. So I'm going to combine like terms. So I would put the 9x cubed minus 3x cubed is 6x cubed. I would do negative 4x squared minus 2x squared is negative 6x squared. There's no constant on the left, so that's like nothing. Minus 7 is negative 7. So there's our answer. Okay, that's all you have to do. And write in standard form, which I did, right? Largest exponent down to smallest. So make sure you put in the right order. Okay. For this one, we're addition. Again, like terms, what's 2x cubed plus 4x cubed? 6x cubed. All right. And then we have an 8x squared plus a 2x squared is 10x squared. There's only one x, so we'll put that next. There's only one constant, so we'll put that last. Okay, those aren't like terms. They don't have any like terms, so just put them in the right spots so you have it in standard form. Okay, so should we miss those either?
No, it depends on how smart you are.
We shouldn't miss those. All right, the next two is product means multiply, right? So we're just distributing. So I'm going 5y times 2x squared. 5 times 2 is 10. On the variables, I always put them in alphabetical order. So x comes before y in the alphabet. If you didn't put them in the right order, I'm not going to mark it off, but that's usually what you'll see. You guys, A's and B's, you'd see A first, then the B's, X's and Y's. You'd see the X first, then the Y's. All right, then also 5y times negative 5xy is negative 25x. And then there's a y outside and a y inside, so that's y squared. Don't forget to add those exponents, the 1 plus the 1. Are these like terms? Could I subtract those?
Yeah.
They're not. The variable has to have the same exponent. They don't. It's similar, but they're not like terms. Very close. So I couldn't subtract those. I'm done. Okay. Any questions on number 5? All right, number 6. I'm going to take the 3x times 2x cubed, and that's 6x to the 4. I have 1x and 3x's. You're adding the exponents, right? Then I'm going to go 3x times negative 3x squared is negative 9x cubed. 3x times 2x is positive 6x squared. And 3x times 4 is 12x. Pay attention to your signs, too. Remember, positive times a negative is negative, right? Then I'm going to take negative 2 times x cubed, and that's negative 4x cubed. And I'm going to line up my like terms. You don't have to, but I like to line up my like terms. Negative 2 times negative 3 is positive 6, and that's x squared. Negative 2 times positive 2 is negative 4x, and negative 2 times 4 is negative 8. So we have some like terms there so that we can combine. So my final answer in standard form is 6x to the 4th minus 13x to the 3rd plus 12x squared plus 8x minus 8. Any questions? Simple, right?
Yes.
All right. We're good on those two, right? So we just take our time. We should get those correct also, right? All right, number 7. We're expanding a binomial. I want you to use Pascal's triangle, okay? So I'll do it over here. So I start with a 1, and then 2 more 1s. The first one we call row 0. The second set of 1s we call row 1. Okay, row 2 starts with a 1. All the rows start with a 1, right? And then I go 1 plus 1, and then I end with a 1. Start with a 1, 1 plus 2, 2 plus 1, end with a 1. Start with a 1, 1 plus 3, 3 plus 3, 3 plus 1, it ends with 1. I can stop there. Why? Right. It's to the 4th power, so I go to the 4th row of Pascal's triangle, right? Or the row that's 1, 4. Okay? Basically, we're looking at that second term in the row to match with our exponent for the problem. Okay?
So why is the first one considered 0?
Because anything to the 0 power is 1.
Okay.
So that's where that first one came from. Okay? So I'm going to do 1, give myself room here, 2 parentheses, plus 4, plus 6, plus 4, plus 1. Okay? That's how we start. What goes in the first parenthesis is x, right? In every one. Second parenthesis, 5. Any problems so far? What if it was x minus 5 up there? We put negative 5 in. Zeros are on top of it. Good. All right, now, don't forget there's exponents we have to put in also. Okay? So, since that's a 4, our first parenthesis has an exponent of 4. And then we go down by 1s all the way to 0 on the first set of parentheses. Then on the second set of parentheses, we always start at 0 and go up by 1. Okay, any questions on the setup? This makes it pretty easy, right?
Yeah.
Now, I also told you anything to the 0 power is 1, so we don't even worry about it when we try to figure these out. So that x to the 0 and that 5 to the 0 is just like multiplying by 1. So we're not even going to worry about it. So then I'm going to go to my calculator and put this in. Now remember, what number is in front of all these x's? 1, okay? So I'm not putting x in my calculator. I'm just putting the number 1 in, or the number in front of the x, the coefficient, right? So don't put x in your calculator. We put the x in our answer, but not in the calculator, okay? So all this is 1 to the 4th. What's 1 to any power? 1, right? So this is just 1 x to what power? The 4th. All right. Then I'm going to put 4, and then remember where that x is a 1 in front of it to the 3rd, and then 5 to the 1st. That gives us a positive 20. So I'm going to put plus 20, and then I'm going to look at my exponent. X to the not my exponent, but my variable and the exponent, sorry. Yeah, don't forget about the x's or y's or whatever's in the problem. All right, this one we're gonna put 6, and then 1 again, and then be squared, and 5 squared. That's 150. That's positive, so I'm putting plus 150. Looking at my variable, x to the second, because that variable has a 2 outside of it, right? And I'm going to go back to my calculator and put 4, 1 to the first, which again, you don't really have to do that because you guys know that's 1. And then 5 to the third. But if you want to do the ones, that's fine. That's positive 500. So plus 500 x. If you want to put the 1, you can. You don't have to. And then the last one is just 5 to the fourth. And you get 625, which is also positive. So there's our answer to number 7, using Pascal's triangle. Questions? All right. Not too bad, is it? Looks like a lot, but calculator does basically all of it for you once you get it set up. We just do one step at a time. It's an easy setup. Colin, you all right? Okay, 2 more to go. Here's a long division problem. Okay, so make sure you use long division. All right, so the 2y minus 1 is outside. And again, I'm looking to make sure I got a y squared, I've got a y, and I've got a constant. If something's missing, what do I put in that spot? Put a 0. Okay? For the outside, you look at the same thing. I got a y and a constant, so I'm okay. All right, if this was a 2y squared minus 1, then I'd have to put a 0y in there, right? But don't have to do that. So now all I do now, you gonna make it, Troy? You're gonna go 4y squared divided by 2y, or ask yourself what times 2y equals 4y squared. And everybody in here knows the answer is what? 2y. Okay? I'm going to take that answer and multiply by both of these, right? So 2y times 2y and 2y times negative 1. And we subtract. 4y squared minus 4y squared is nothing. 12y minus a negative 2y is like adding 2y, right? What's 12y plus 2y? 14. No, not negative, just 14. And then bring down the minus 12. Start over. What's 14y divided by 2y? Or ask yourself, what times 2y gives you 14y? 7. And that's a positive 14y. So it's positive 7 plus 7. And then I multiply again. 7 times 2y. And 7 times negative 1. And then I go ahead and do that subtraction again. The 14y minus 14y is nothing. I got this minus a negative again. So it's negative 12 plus 7, which is negative 5. So that's my remainder. Okay, so I'm going to write in my answer plus negative 5 over what?
2y minus 1.
Right, the 2y minus 1, what I was dividing by. Questions? I think we got this down now, right? The long division? Okay, your problem, not mine.
You can tell my mom.
Anybody else got a question? Okay, the last one, much easier, quicker, because it's synthetic. The only mistake that usually gets made is right in the beginning. What number goes in my corner here? Positive 1, yes. We all understand why. Okay? So if that was x plus 1, we would have used minus 1 or negative 1. Thank you. So if this was x plus 1, I was saying negative 1 would be in our corner. We all good with that? That's usually a mistake that gets made if we make one on this. Now, we got an x cubed, so we use our 3, our coefficient. We have an x squared, so we use negative 5. We don't have an x, so what do we use? 0. Yeah, don't forget to put the 0 in. That's another spot where we might make a mistake. And then the minus 2 on the end for the constant. Remember, make a line, drop the 3 under the line. So that's what it looks like when you start. Get it set up. Any questions on getting it set up to divide by synthetic division? Okay, so now all I do is multiply 1 times 3 and put that answer above the line right under that negative 5. Now I do what with negative 5 and 3? Add them, yes. So negative 5 plus 3 is negative 2. And then 1 times negative 2 is negative 2. And then I add 0 plus negative 2, and I get negative 2 again. And I multiply 1 times negative 2 again, and get the same answer of negative 2. But now I go negative 2 plus negative 2 and get negative 4. That last number, remember, is our remainder. Okay, sometimes it'll be 0, that's great. But if it's a number like this, make sure you put it in your answer. Now, here's another spot where some kids will make a mistake. My answer is 3x to what power? Squared, yes. We started out as x cubed, but it's always 1 less in our answer. So this is x squared. So sometimes that's where we make a mistake when we write our answer, okay? And then minus 2x, minus 2, and then our remainder. What's my denominator?
X minus 1.
Thanks. So, will this be that difficult?
No.
No. You guys are going to do really well tomorrow, right? We're going to have positive thoughts. Okay? No questions? All right. Good job. Thanks for paying attention.